This is Physics 2211, Lab 4, Oscillations. The purpose of the lab was to learn about the relationships between gravity and spring force in the oscillation period of a spring based on the mass and the spring constant. The fundamental principles for this lab are Newton's second law and F equals ma, and gravity and force of a spring is negative k L minus L naught. The results of the lab will show a spring will oscillate at the same time interval with the same weight. The system is the mass in the spring, and the surrounding is the Earth. The initial conditions are the position of the velocity of the mass, and the experiment is just pulling a spring down and releasing it so that it oscillates in the x and y direction. This is the data gathered off tracker for 95 timestamps in the lab based on the time for the x and y coordinates of the mass. On the left is the calculated based on the formula for the oscillation period of a spring, and based on the tracker we get the oscillation time based on y is 1.95 seconds, and based on x is 1.614 seconds, which is really close. And then k, the spring constant for the spring, is 6.874, and the L naught for the spring is 0.114 meters. This is the code. So the first box on the left is setting the initial variables for the position of the ball and the mass of the ball, and then below that is the initial variables for the spring constant, L naught, and the initial length, and the length, the vector for the length, and then the kinetic energy, gravitational potential, spring potential, and total energy of the system. And then the rest of the code is in the looping through and changing each of those variables based on each timestamp to find the change in the spring constant and the gravitational potential and gravitational spring potential and the total energy. These are the resulting graphs from the code. So the x position, or the y position versus time, is pretty different from the model due to error and the code not matching with it, but the x is the same or similar with it as the experiment shows. And then the top left is the measurements of the change in the spring constant, the potential gravities, and the total energy. And it does follow the energy principle because the total energy stays zero, so it's not changing, which means the system's energy stays the same, which is the definition of the energy principle. In conclusion, the possible errors in this experiment were messing up in tracker, not tracking the exact center of mass, not having exactly perfect timestamps, and giving the spring an initial velocity as he released it in the video. And this lab means that a spring does oscillate at the same time period based on the data and the model with the same mass and the same spring constant. It supported the purpose because we were able to learn about the relationships between each of these things and prove the spring constant and mass are the only things that change the oscillation period of a spring.